Hello. I just wanted to say thank you for all the new subscribers to the channel and the old ones too, and all the questions and the nice comments and the thumbs up and the sharing and but it's been a crazy ride. YouTube has said that since in 28 days I've had over 5,000 new subscribers to this channel, and that's an achievement, and I appreciate every one of y'all. But when you click on those likes and stuff like that, it generates more watch time, I believe. I'm almost at 4,000 watch hours, and then I can get benefits through YouTube. Now, I will set up a Patreon, and that's where I'm going to have SDL files available. And and then I'll have listings of like maybe servos and hardware and what to get and things like that to make this animatronic work. I'm going to have other files available, but it's just setting everything up. But YouTube has also some kind of sub subscription deal, or to where you join my thing, or it's something that I'm learning, and I might have two of them. I just don't know at this time. I'm just trying to set everything up. It's just everything's just been going so fast, but we're going to take care of that. Plus, I've been designing, as you see here. I shot, I did screen capture of 5 hours of footage, and I got it, edited down so y'all don't have to see all the studying part of the whole animatronic. But you'll understand that when you start designing your own. And eventually that's what I want y'all to be able to do, because it's just a special feeling when you design your own. And that way it's just a good feeling. But what I'm doing here, this is uh the designing of the so-called brow mech. There is three servos that are going to be mounted to this so-called, I'm calling it a scaffold now, because it kind of looks like it after you see it finished. And it really turned out well. And I go by the pre-existing shapes that I had put these ribs on the last video that we've seen. And I'm going by that as far as height and length. And I'm kind of doing a kind of a block version of not so rounded, because you'll see later, uh, I will put magnets for the skull to attach, and it needs to be a flat base, and then I have also screw points, and you'll see me, and I've been making screw points today, but it's coming along. I have it all mixed together here, just to so I can see what I need to do with these blocks. And I'm just trying to attach everything to this iMech, or the Blake mech part. So what I'm going to do is manipulate this part of the iMech that I don't need, and this is where the servo lays. So, and this is they call this uh let me see. Yeah, they call this intersect faces, and but that's what I've been doing, using here. I'll put a block there, and I'll highlight that one face, and I'll right click and say interface with face, and it will just know what's surrounding that face or what it's into, and then it'll copy the so-called new lines or vertices to that shape, and that way I can go in there and edit. Now, some of the complex shapes, you have to seriously do some editing, but it works 95% of the time really well. And a lot of these videos I have sped up, and this is like time 6, because once again, I probably put in so far on this one project, and I can get a pretty good calculation, but I probably have close to 30 hours if not more, into this animatronic here. And it's the design thing. I mean, everything that mechanical especially has to be designed. And it's just that it can be kind of tedious when you're doing it with this uh, with any kind of software, because you're looking at it a three-dimensional object on a 2D monitor. So it kind of gets kind of strange to do that. And plus, something so, if it's the size of your monitor screen, you're thinking this thing's big, but yet it could be size of your hand, and it can kind of throw you off. But I'm just working on this iMech part, or the blink mech, and just trying to get a base for me to connect that so-called scaffold, uh, the brow mech scaffold, to this area here, because I'm going to put screws in there. And I determined that this is where I want it to be, you know, fixed to with some screws. And I'm going to use 2 screws right here, but it's mirrored, so they'll have 2 other screws there, but plus there'll be 2 on the back end ribs, and you'll see that later on. But this is just me how I'm forming this little area to make the mesh to have screw points. Now you'll see me jump around, and I'm working on a platform, and this platform here is going to be holding the so-called the blink mech mechanism, and it's, the servo sockets, and that's going to be its area. And then this so-called scaffold is going to attach to it, and then then you have the eyelids, then you have the beads, and then so on and so forth. It's just, you're making everything kind of modular. Now, you'll see it later on in the design, the so-called the brow mech uh, you know, scaffold. You'll see that I'm probably going to print it in one piece. I have joined legs to of the object, and then try to break down so many into multiple smaller pieces, mainly so I don't have no support. But this thing is just so, it's a good size, and you'll see later. It's just that, I'm not a big fan of supports, but sometimes you have to do it. But I'm trying to, maybe less parts to print, but this would just be one major part, because it holds the brow mechanism, it holds 3 servos, and plus it's going to be supporting the skull lid itself. And that's what I've been prepping for by designing this whole thing, to do all of that whole process of kind of, I have, like here, they're mirrored, and they're not, and whatever I do on one, it's going to be copied to the other one. So before I, release the so-called component and make them non-mirrored, I can join it as one. But anything that I do on one, I'm going to have to do on the other. So it's best to do all you can on one side as it's mirrored. Someone had a comment that I could do a, reduce the poly of my ZBrush design, from, reduce the polygons to where it won't be such a big, large file, and would be able to put it inside SketchUp. And I've done this a number of times, and especially when I was working on on the Hulk character, I'll do that to get kind of a size ratio of the skull that I want to build for it. But what happens is that ZBrush is primarily on units. They're not on like a metric. They do have a measurement thing at the end, but it's nothing like you have some kind of like a ruler or anything like that. But ZBrush has Decimation Master, where you can reduce the polygons. Like if I have something that's 200 megs, which that would be a pretty good size size file, I can, turn it into something like, just a couple of megs to put it inside uh, SketchUp. And like if I did the sculpture and I put it on here, and I've done it before, it's just that my measurements are somewhat off. Even though it says it, I'm not getting that same measurement. It's a little off. I like ZBrush, don't get me wrong. It's just that there's some things like it can't handle a large, like my large Hulk creature I'm doing. It's a 17 inches from the chin to the top of the head, and things that size, uh, it really doesn't like things that big. You have to reduce it and then relarge it, I guess, to that original size you want. But I think you're limited. But yeah, once again, I don't know everything about ZBrush. I mean, I'm no whiz at ZBrush at all, and it can do a lot that I've not even touched the surface of ZBrush. I'm just in there to sculpt monsters, basically just skin for my creatures, and I'm just getting by. And I try to use multiple tools, but it's only a few handfuls I really like to use. But as far as um, designing on this brow mech here, I'm kind of closing things up a little bit so I can remodel the shape. And there's a certain shape that I see that in my head that I'd like to have. And plus, it needs to have clearance through everything. And also, I need to be able to get like my my fingers in areas that might be kind of small, or I got to make sure that if I need to screw a nut in place, I need to be able to get to it. But like for instance, this whole rig, the scaffold that I'm building here now, I'm going to have to put the servos on first and then lay this onto the skull itself or onto the main base. And then I mean I can still manipulate it to a point, but that's this other things that you have to calculate. Even I've had some other smaller animatronics where I had to put screw or screwdriver holes into certain skull areas, so if I needed to adjust a screw or whatever, I could do that. But see, when we're doing an animatronic with skin, soon as you attach the skin, everything needs to be done with. And but once again, anything mechanical is subject to failure. That's all mechanical objects. There's always that possibility of having something fail, but we're just trying to avoid that, and we don't want that. Nobody does. But that's when you put in the hours and days and weeks and months into something, that's what you're trying to avoid, to have to fix something. So, and like I'm trying to make this thing somewhat durable too. You know, there's other there's other ways to print this, and and also I'd like to see some of my things milled out of aluminum. But once again, I don't think like this size of this scaffold. I mean, some of these things are 6, 7 millimeters thickness, but with metal, I could reduce that half, if not more, and then add also uh, threaded screw holes there to just bypass any kind of a nut mechanism, where you wouldn't have to have you know, a lock nut situation, and that would save even more space. And 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 that's another thing about animatronics. It's all about space, and you got to have clearance for your linkages, and your linkages have to have clearance also, so they don't bump into something. And then Then you have your wires coming from your servo, and they have, these leads that you need to slide them through them holes, and they might have to travel through multiple floors so you can get to either a servo controller or some type of receiver. And but it's all in part of the design. But here, like, I'm working on the table, and this is a new table, but it's going to connect everything from the top up. The new brow scalpel, and then the eyelid neck, and all this has to be where I want screw points to connect all that stuff together. Now, the the eye blink neck will be connected to that plate already, and then that will be one one part. And then I'm wanting to get the another. I'm making this plate thick enough so I can cut it flat right down the middle of this thick plate, and then I can print that one plate, and then I can print the so-called uh, mouth neck plate, and then that way I can just screw everything together, one time. I mean, it's going to have a lot of screws because you have to calculate the servos, the linkages, and then the whole prints that you have to screw in place. And then there's going to be nuts and washers and things like that. But, sometimes you try to eliminate a lot of that, but it makes it fluid, and it makes it strong and durable. And also on that main support plate, I'm going to have a gimbal, and that's going to be on the very back end of the skull itself. And then, but the main plate will also have a so-called border, and that border is going to be from what I build upon the skull. And the skull border has a thickness, and that's the thickness of the shell skull part. And then you'll see here later on the scaffold where I'm adding these boxes, and I'll probably point it out to you in this video, to where I'll have these neodymium magnets set, and then they're going to have opposing magnets that are going to be part of the skull. So that the whole skull will just click into place and fit correctly. But I just design these things because everything is going to be covered with silicone, and there's going to be some places that are going to need to be glued, the silicone to the so-called skull, and there's some stationary points to the skin where that part of the skin doesn't need to move. But on the other hand, that I'm going to have some type of skull plates in certain areas just so I can stick glue or the silicone to the skull. And it's just designing a whole cover system for the entire mech. But like under the eyelids, there's going to be a skull part there too, because I want something to be glued underneath those eyelids, so it will make. I don't want the whole, I guess, the whole bag of the eyelid to move. I just want the eyelids to move. Yeah, I like designing all these things. I mean, it's pretty relaxing, but once again, that there was 5 hours I recorded, and that's what I'm editing right now. And I edited down. It was 5 hours, and there's mess ups that I do that I edit out, and I'm talking about mess ups like the hourglass that comes when your computer kind of freezes up when you're doing too much work or something. I have that you know all the time when I'm designing, and then it'll freeze up for a minute, and I have to edit that out. But then there's other things where, well, there's no sense of me showing you that because because there's things that I add to this design that I changed my mind. I says, well, I'm not going to go that route. So, and then I'll just edit that part out. I mean, I even did a smile mech to where the creature would smile or frown. It'd give more of a cheek movement. And I could probably do it, but it's just, once again, every movement has another servo. And I'm trying to keep costs down. And it's cost down for y'all guys because it's like, you know, you got to also understand that uh, animatronics can get very, very expensive. And I'm trying to keep this, low cost. I'm trying to do a really good multiple movement expression animatronic lifelike for little or nothing. So, I mean, and y'all see, on that little creature test that I did, that so-called proof of concept, you know, uh, you know, I've been wanting to do that for a while, but I was so busy doing Grogu's. I mean, but I got to the point to where I just did a little test just to prove and I've had this so-called theory for mainly a good 10 years. I mean, I knew the technology of 3D printing because you could see on my other YouTube channel that when I made the old school way of animatronics, I mean, I was making these little blocks out of polyurethane. I would pour it and then I would cut these blocks and make these so-called shapes. But now I'm doing the same thing with 3D printing. And that's eliminated that so-called process. So now I can do it this way. But, it's like the old school way. You could do a sculpture, make a mold. Then after you made the mold, you'd have to put a layer of clay inside the mold. And then when you did that and the mold is closed, you would have to pour another to make the core. And when you demold, remove that clay, you have a core. But then you had to mold the core to make the skull. And then to make the skull, you had to either make another mold or do what they call a slush mold or a rotational mold where you build up a layer of solids with polyurethane and you would have a shell. Well, as soon as you do your sculpture and you molded that, and then you molded your core, then you molded your core to make the skull, you're thinking, well, how many servos can I use? Well, you really didn't know. I mean, you knew what you had to do, but you would hope you would have enough room. But by doing it this way, it's kind of reverse engineering to where you do your mechanics first, and then you make your skull, and then you do your sculpture, and then, I mean, there you go. You done reverse engineering. But you can take it further by you can get your basic movements that you need. If you start designing a lot of animatronics, you'll develop a so-called library of parts. And then you can take these parts and use them on this, if you're going to have a so-called alien or a creature that has like a more human look than more of a like a werewolf look or a dinosaur look with a long muzzle of some sort. You can change it. I mean, the eyelids are eyelids, so you can just enlarge them to any size you want to. But like this plate right here, I'm trying to build up an area at the back because it's too short. And and then eventually you'll see me pull this back. I don't want it to interfere with that border with the skull. And that skull border has a measurement of like, I think it's 3 millimeters or 3.5, and that gives the thickness of the skull. But I mean, you'll see later on how I develop the skull. It's going to be the whole process of this, but you'll see me put this skull on here, and this was from the last video, but you see how much space I have here available. I'll remodel this again to fit that border, which is already close again by me just stretching it here, but I want it a little bit more precise. But you'll see here I'm joining the scaffold together. And this little square right here, that's where the magnet's going to go. And you're going to have a mirrored magnet on the other side also. And then on top of those, you're going to have the opposing magnets, and those opposing magnet sockets are going to be attached to the skull. And if you do all that, plan it and go by the borders, the whole skull will fit like a glove. But no, it's a wonderful feeling doing these things, and there's a lot of softwares and servo controller softwares. There's some that make things look robotic and some cheesy, and I like when I can have multiple movements going on at the same time. That's called like a mixing. I like that, and VSA is one of them. But once again, you're stuck on one software, and that's what I prefer. And but I want y'all to be able to make that. You can say I made that. I want y'all to be able to design your own animatronic. And it's not that. I mean, don't get me wrong. You have to put a lot of time in it. I mean, you have to, but you can start off small. You can do an iMech. You can do a blink mech first, and then a lot of times, you take you an eyelid or take you some beads. You can take a bead, get the measurement, and then make you some eyelids, and then you get a servo to move those eyelids. Then you're going, wow, that's cool. Well, now you can take that eyelid and mirror it and have two eyelids. And then you're going, that's even cool. Well, now you can enlarge it and get you a larger bead and make you a bigger one. Or better yet, you can reduce the size and make you something smaller. But then it goes on and on. You can have the same servos and the same, if you plan it right with the right servos, if you plan it right, if you enlarge the screw points of a micro servo, enlarge it to a standard servo, you can make your animatronic that much bigger. Instead of something that's, I guess, bigger than a softball, you can enlarge it to a basketball size. I mean, by but don't get me wrong, you still have to make some minor adjustments because most standard servos have 4 screw holes than just 2. But that's nothing to it. Just copy, move up, copy, move down. You have 4 screw holes. And another thing about designing is measurement. You're going to have measurements. And you check again, and then you double check. But that's just something I've always I've been doing it. And a lot of times for these big animatronics, uh, it's nothing for me to take this, like this big Hulk creature here. It's nothing for me to take this thing apart 15 times. And it's not to fix something. It's to maybe adjust, or maybe let me move this way to get this effect, or I got to make sure that it's fitting correctly, or it could be a lot of things, or just to modularize everything. Your eye mech, your mouth mech, your brow mech, your ear mech, your gimbal. You have all these things that when you make all these so-called modular designs, you can put them all together and you'll have a whole animatronic head. And when I start printing this animatronic, I'll film the whole process of me building it, and probably give an estimated time from start to finish, and it will probably take a few hours to put together. I mean, if you just screwing in place 8 servos and then sliding all the parts into their places and screwing them parts down and stuff, and you can pretty much build it. And as soon as that is done with, is you can connect it to a gimbal. Then after that part, you'll be able to set up a program with your radio. I always test everything that I do with a RC radio, and I have posted that in the comment page on the YouTube channel. And you can find you any radio that you really like or you prefer. I mean, it doesn't have to be expensive, and some of them go up to $1,000 or even more dollars. You can have a little basic $50, or I've seen them as low as $30. I would prefer you'd have more than 4 channels, but you're primarily going to be using 4 channels anyway. You'll have some finger dials that you can use, but mainly most people, as far as most people that are doing the so-called puppeteering, are primarily just using the joysticks, and that's just 4 servos or 4 channels. But that's going to be a must to get when you're doing this, because you need to check your movement or your center point of your servo. And right here on the video, you'll see me centering that to the plate. And that's another key point that we have to make sure that we do. When you do this, the plate, you find the center of the plate, and then I find the center of the scaffold. And you see me here adding the so-called border that I was talking about for the skull. And this is the border that we're going to be using, but I don't need the center part, so I'm just going to add these vertices here to make it where I just make a continuous loop all the way around, and I'll just mirror that one side and put it in place. And then on this, I raise the upper lip up, because I'm going to need some kind of a shell cover for this mouth area, and not knowing if I want the lips to go up inside of this, but yet I kind of want it to like wrinkle the creature's nose, but yet it still needs to have something there for the nose to lay upon, because I call this, you don't want it so baggy. If you don't have anything there, it will be baggy or have a raincoat effect where it looks kind of rubbery mask type look. So it needs to lay upon a skull. But now here, what I'm doing is I'm finding the center axis, or the center point to where these eyelids and this eyeball is. And I'm going to be making a circle, and I'm going to make that circle in half so I can give it some rotation to make a so-called the eyelid eyeball mechanism, the hole in the skull part. This is what's going to connect the skull, like the bridge of the eyelids, I guess you would call it. That way it will, this is where the hole going into the skull will be from. This is what it will become. But it's, and this is something that you'll notice, that when you rotate the servos, the servo linkage that is on back of or linkage point that is on back of the eyelid sticks out somewhat, because when the servo linkages are pushing the eyelids, that so-called linkage socket is visible. Well, I don't want it to bump into the skull, so I have to close the eyelid so I can design around it. That way I don't have any kind of interference. But and don't get me wrong, I've had that problem before, but now I've learned from that mistake or that issue, and I always try to correct it to make sure I don't want to have to go through that. Because once again, you don't want to print something for 12, 20 hours and have to reprint it or even redesign it. So it's best to just try your best to eliminate all that. And even if it takes you a couple of days of redesigning or design it right the first time, but it's just part of it. But like, this is the thing about SketchUp that's kind of hard to do is when it all depends on what view you're in, but also when you're rotating at an angle and not rotating on an axis, you got to kind of have I guess you have to have a so-called flat base or it will not rotate correctly. And that's what I'm kind of having to add here. And that's just, where I can change my axis according to the flatness of that plane there. But, it's just part of it once again. But, also, I've worked on the main floor plate. I worked on the eyelid socket area for screw points to do the scaffold that is the brow mech. And then also I have the border for the skull. Now I have the so-called socket areas for the eyes for the skull. And I'm getting close to doing the skull. And then I got to do the underskull also. That way I can kind of, more likely I will have that form placed on there to print when I print the bottom plate. I want the bottom plate to have that already on there and just making sure that I can do that when I print it. But then it might also be where the mouth mech area might have the cut part of that bottom skull plate too. But but then I got to redesign the teeth and then after I redesign the teeth, then that way I can finish out the so-called lips. But lip pieces and hinges, the little small parts like that, I can make adjustments. I can finish them and do the best I can, but they don't take long to print at all. But as you see here, I'm checking all my measurements. Now I'm going to have to readjust, and I just figured this out earlier when I was editing that I'm going to have to readjust the so-called scaffold, the bases there where the screw points are. I'm going to have to redesign to where that's going to print flat. I'd rather print it like it's laying there like it is there on a flat plane like so, but those legs need to be even. Like I'm going to have to reduce the height of the back ones up to match that height. And I know y'all are wanting to join Patreon, and I'm wanting to know if there's going to be people going to be wanting to join the so-called uh, membership on YouTube. I mean, this is something new to me. I've known about it, but I've always known about Patreon, and I know what Patreon does and how its file format is, where they share files and things like that, or or videos. But uh, but plus, I look at having some kind of income so I can invest in research, like in servos, and because I study servos really and and it's really a process that I go through, that I like a servo to be a certain type. I don't, I try to do uh, a good review on servos, and that way I, and other things also, like, certain hardwares or softwares or just so-called components, servo controllers. But I, I love a good servo, and if it's good, I'll use it. But there's one thing having a servo that works hard, great, it's quiet, has good torque, and it's a great servo. But if it costs $200 a servo, I really don't have a need for it at this time in my life. Because if I need 20 of them, I can't afford that. And but there's servos out there that are that expensive. I can't afford that. I mean, I'm in the $20 range, if that. If even $20 is kind of high. But I'm into you know, the $100 servos. I mean, it might be a name brand, but I'm trying to achieve this quality. I mean, those servos in that little small creature test. Those ser though there were, let's see, what was it? Two, three, four, five servos. Those servos were less than $20. I mean, and I got that achievement of that movement with that silicone. Now, silicone's expensive too, but that's just what you have to do. I mean, but I'm, and that's why I'm doing the size that we're doing here. To make it the size that we can make this affordable, because we're going to have to mold this, and it's going to be like, it's smaller than a dollar bill, but it's still like a size bigger than a baseball. But it's going to be it, you're all going to love it when it's done. But I rattle on about animatronics because it's just an obsession I have. I've been doing it for a long time, and researching it, and I've researched it for a long time, and it's part of the passion. But once again, this is probably one of the longest videos, I believe. I'm not quite sure. I have to double check. But this whole video here is 44 minutes long. But it was from a 5 hour, I mean, I was up last night for 5 hours recording this whole process that y'all see here on this video. Uh, from It's just a breakdown of everything that I've done throughout the 5 hour period of doing it. But it's it's great, and I'm loving it, and everything's coming together. But once again, I thank all of y'all again. Just thank you for subscribing to my channel. Thank you for the comments, the likes, and the shares, and I appreciate all of that. And I'm trying to get the 4,000 mark. I know it might have ads on my video, but it's the way I can produce some kind of income to support this channel. I need to have some kind of support. The Patreon is coming. We'll have all the files and all that other merchandise stuff like servos and stuff. When I get all that, will be there more than likely. The membership stuff I'm still thinking about, but that's going to be like a primary, another source of income through YouTube, where I'm going to be, helping to research and do reviews and testing and things like that. But I appreciate every one of y'all, and thank y'all for y'all support. I hope I'm giving y'all good content, so let me know later.